Hi sir, this is Lauren Meditalo from BS Mining Engineering 4, and I am going to present the general principles of mine design. So, mine design includes a systematic process of determining the optimum arrangement of equipment and personnel to extract ore reserves productively. Key components include geological assessment, extraction method, selection, mine layout design, and economic analysis. So, first is the focus of mine design techniques. So, mine design techniques has four key takeaways. So, first is the investment scheme specification. So, identifying the most reasonable investment schemes custom made for the improvement of economically viable mineral deposits. Second is the optimization of design parameters. So, fine-tuning the basic design elements for both new mines and those experiencing reconstruction to attain the highest profitability within the chosen speculation framework. Third is the implementation of technical designs, executing the necessary technical designs required to bring investment projects to realization, ensuring practicality and productivity in implementation. And lastly is the feasibility analysis. So, in conducting comprehensive assessments to evaluate the feasibility of various design methodologies, determining the most viable applications for each approach. So, second is the systems approach. So, first we have the increasing complexity. So, acknowledging the growing complexity and scale of challenges faced by designers in different areas. We also have design methodology system, establishing a systematic design methodology that can viably address and solve complex design problems. We also have comprehensive design. So, comprehensive design is recognizing the need to design not only the technical perspectives of a facility but also considering a range of materials and organizational conditions significant for its viable operations. Next, we have the system perspective. So, system perspective is viewing the mind as a system with interconnected components and external conditions that are fundamental for its existence and operations. We also have the subsystem considerations. Subsystem consideration is breaking down the framework into subsystems, each with its own goals and scope, and addressing them independently in the design process to ensure holistic and viable solutions. Next, we have the system designs. So, complex solutions, emphasis on looking for comprehensive solutions for complex systems, considering their complex nature and different interdependencies. We also have interdisciplinary approach. It is utilizing an interdisciplinary approach to design involving ability from different areas to address the multifaceted aspects of the system. We also have application modeling methods. In application modeling methods, it is employing modeling methods, particularly numerical modeling, to facilitate the attainment of optimal solutions. Next is the challenges and complex analysis. So, recognizing the difficulty in reliably analyzing and optimizing the entire system as an entire due to its complexity. Also have successive analysis of subsystems, conducting successive analysis of individual subsystems to realize partial optima, which contributes to the improvement of an optimal generally conception. We also have the consideration of characteristics. So it is to determining the input and yield characteristics as well as the estimate and structure of both the whole framework and its person subsystems to encourage the plan, prepare, and improve overall effectiveness. Also have the designing a mine as a system rather. So first we have the systemic perspective. So it is recognizing a mine as a complex system, considering variables such as the scale of investment, technological forms, and the interrelationships among different components. Also have the importance of subsystems. It is the understanding that the right selection and facilitated operation of all subsystems inside the mine essentially affect its generation and cost effectiveness. Last is the natural deposit conditions. It is acknowledging the significance of natural deposit conditions in mine design and operation as they impact the overall viability and feasibility of mining activities. Next, we have the mine model. So, mine model has spatial organization, which is the understanding the spatial course of an action and interconnection of essential mine components such as shafts, floats, crosscuts, extraction phases, advancement workings, and pit bottoms and pit limits. Also have the components of processing. So in components of processing, the preparing plant as a significant component inside the mine show counting haulage courses, stores, workshops, and assistant of offices found both on the surface and underground. Next is the elements of the mine technological process. We have the focus on production elements, prioritizing the elements directly involved in mine production as the most critical aspects. We also have the uniform production capacities, ensuring that production capacities of these elements are consistent and aligned to avoid bottlenecks or inefficiencies in the mining process. We also have protection of extraction areas, implementing measures to safeguard extraction areas against disruptions in the main haulage system, especially during periods of high productions. We also have the importance of ventilation and drainage. Recognizing mine ventilation and drainage as essential components of the production process, operating independently but crucial for ensuring safe and efficient mining operations. Next, we have the mine production flow diagram. So, in mine production flow diagram, we have conditions for establishments. So, it is it identifying the necessary conditions for creating a comprehensive flow diagram for mine production, including ensuring adequate production capacity or across all sectors, maintaining safety for personnel, compliance with regulations, reliable operation with minimized breakdown, and minimizing labor requirements. Next, we have optimization objectives. So, optimization objectives aim to achieve maximum concentration of production, maximize exploitation of the deposit, and maintain a flexible design to adapt to changing conditions. We also have cost considerations, striving for minimum investment expenditure and production costs while maintaining efficiency and effectiveness in the production process. Next, we have mine infrastructure. So, utilization of existing facilities, maximizing the utilization of existing infrastructure such as rail and road networks, water supplies, and power sources in the region where the mine is located to optimize operational efficiency and minimize construction cost. We also have pre-construction facilities, establishing necessary facilities before mine construction begins, including access roads, power networks, and telecommunication facilities to facilitate smooth project execution. Lastly, we have environmental protection, prioritizing environmental conservation by preserving clean air, minimizing noise, vibration, and dust generation, protecting soil and groundwater, and preventing pollution of surface water from underground sources, thereby ensuring sustainable mining practices. And lastly, we have the optimization of the design systems. First, we have the significance of correct choice and coordination. The correct selection and coordination of all production elements significantly impact the economic efficiency of the mining system. We also have challenge due to natural deposit conditions, so the optimization of the mine system is challenging due to the dependence of production elements' natural deposit conditions. We also have role of mathematical optimization and computer techniques. Advances in mathematical optimization methods and computer-based engineering calculations enable feasible optimization of mine system. So have heuristic method, utilizing heuristic methods for problem solving, which may not guarantee optimality but are sufficient for immediate goals. Next is importance of realistic modeling. Minimizing simplifications in modeling leads to models that closely simulate reality, enhancing the accuracy of the design process. And we also have three stages of mine design. The mine design process consists of three stages. The first is the conceptual, preliminary, and final, each requiring different levels of accuracy in the mine model. And lastly, we have the incorporation of further knowledge. Continuously incorporating additional technical and economic knowledge during the investment and extraction phases can lead to further improvements in mine design and optimization. That's all. Thank you.